So this is a really a talk for those who are just learning, okay, Kubernetes observability and how to look at the data-driven observability around Kubernetes, and a little bit about security around stateful applications. So most of them, Victor can do whatever he wants and does great YouTube videos, and he's invited to these talks. But he's not limited. I was told, right, Bart, that I need to pre-record the demos. So yeah, so I'm going to, all the hands-on stuff is pre-recorded. I'm going to show you a few slides, okay, about what I'm going to show you. Then we are just going to view together a video I created yesterday. So just really a few words about it, because about me, okay, I'm CTO of Armo, a small Kubernetes security startup. I'm coming from the deep security world into cloud native, and giving a lot of talks lately. So what I'm going to show you, I'm going to show you a very simple setup of Minikube with MongoDB installed as a stateful set. Okay, we're going to look at Kubernetes Lens as a way to observe, okay, this application, okay, how the stateful set looks, PVs, PVCs, and disk usage. Then we are going to look at a little bit my, the project, okay, I'm maintainer with Kubescape, we're going to look at the security of this application. We'll look at vulnerability scanning, okay, and how is RBAC looking like. Then, we'll do a little sneak preview of Grafana and Prometheus, how you can view this application under this. So it's really for us to begin with. Let me check the video. This is, I hope so. You see. So again, we're starting by a very simple Minikube. Okay, I've installed with Helm Prometheus, Grafana, locally with installed MongoDB, okay, from Bitnami, okay, installed Kubescape as an operator, and just took the secret of Grafana, so later we can log into Grafana for the first time. So as a first step, okay, well, I'm going to show you that everything is running here, as expected. So you can believe me that everything is here and right, okay. And the our MongoDB is here, and we are going to Kubernetes Lens. Okay, under Kubernetes Lens, okay, you have my Minikube, and I have to tell you that at the end I connected also one of my Jenkins instances to show something. But in general, if under Kubernetes Lens you're opening the cluster, okay, you'll get a few nice overview about what you have, and you have these stateful sets under the workload page. Within the workload, okay, you can see these different parts, okay, of the workload definition, and you can see this single instance of pod, okay, under its instances. And you can go scroll down, okay, and what you can see here is actually the most interesting thing we have here is actually the volumes and the mounts. Okay, we have the Bitnami MongoDB directory, and what you can see below, okay, if you're looking at your stateful set, is actually the persistent volume claim we all longing for. So if we're looking inside, okay, we can get information, okay, about the persistent volume claim, okay, when it was created, its size. Honestly, I really tried to hook up to the disk information, okay, inside Kubernetes Lens, and the result of all of my trials was a bug issue I opened on Lens, which was accepted. So they need to solve some issues. So I reconnected to an actual live cluster we have with Jenkins, where we have under the stateful set, we have Jenkins, and here we can see a little bit more about the disk itself. and what we have, under the file system inside Lens, which is pretty neat because there is always this discussion whether we as hands-on people we like a UI or not. I do think that though I really like CLI, UI can be very, very helpful, especially with debugging and looking around things and understanding them really, really, really fast. But in this case of this Jenkins instance, we have a real volume, EFS volume behind this volume claim. And you can see here, actually, the volume claim should be, if I remember correctly, I found it a little bit later, downwards. EFS claim. So it's always the question, of what kind of volume you want to use under AWS. I honestly, in case of Jenkins, I was really preferring EFS instead of EBS because of the debuggability around Jenkins. I like to back up stuff outside the pods and stuff, and therefore I really like the EFS and its usability, so I can have another machine bound to that same file system and talk to it. Obviously, on the other hand, there are performance issues with it, but in this case, we are not really caring about it because this is not a high load system. So going from this, return to our Minikube. We can see also that within the Lens, we can see Kubernetes events which are popping up. So those who want to, have observability inside can see them. So now we are switching, if I remember the recording correctly, we are switching into the security space. Sorry, I want to skip here a little. So as I told you, I've installed Kubescape operator. Kubescape is an open source security platform for Kubernetes, which is scanning for configuration security issues and vulnerabilities in your cluster. So I went to the UI. In the UI of this cluster, which I call demo minikube, I'm going to check out all of our security controls. And first of all, I want to see only the failed controls and then those with the highest severity. And then we can see a few interesting controls. One is that we are seeing here a privilege container. So privilege containers are sometimes in Kubernetes. Therefore, we are saying, well, we accept it. On the other hand, we see that there is a potential security issue in the stateful set of MongoDB because this control failed because it thinks that there is a credential inside the YAML file, which is kind of funny because honestly, I think that this can be an issue in Kubescape itself because the definition, it thought that there is a password inside the YAML file, which weren't. But on the other hand, it was a security issue in the sense that you allowed empty password files, which are not really good. So another control is which pods have network access. In this case, these all were good. And while we are reviewing, also the security issues, there is another security issue which is called resource limits, which is both a security and obviously an operational issue. If you're not putting limits on your workloads, can be an issue. And this is in this case Grafana. The Helm chart came without limits, which is not a good idea. And also MongoDB stateful set for some reason by default is not coming also with limits, which is also not something good. So in general, this small cluster can give you half an hour work of reviewing all these potential security and DevOps and operational issues. Beyond that, I don't remember if we have here something interesting, like things like etcd is not encrypted. Also, whether hostPath mounting is acceptable for these workloads. In this case, all of them are known workloads, so I've said that I don't want to see them. So we're heading toward image scanning and vulnerabilities. So within Kubescape operator is scanning your images in your Kubernetes cluster. So there's a good question of whether you should scan your images, in your registry when you're creating it, or you should also scan them, inside the Kubernetes cluster. And if they are already scanned as part of the registry or even before, why you should scan them inside your Kubernetes cluster? Does anyone know the reason why? Sorry? Yeah, because vulnerabilities are, is not a constant. It's not one thing. Okay, every day we found new vulnerabilities. Okay, and one day we don't have a vulnerability in our application, and the second day it turns out there is the log4shell issue. Okay, and then we'll get a different. Therefore, we must monitor, okay, our images inside the Kubernetes cluster. So in this case, we have monitored the MongoDB stateful set. Okay, and we see that there is a single critical issue. Okay, so at the end of the time, if Bart says that I have 2 more seconds for me to show you something cool, hopefully I will be able to show you something more interesting about this. So I'm also showing here the RBAC, okay, of this cluster. Okay, what with the different roles and bindings and the different subjects you can review inside your cluster, which is super interesting. Okay, when we're talking about security observability. Okay, and I really suggest you to a little bit monitor the RBAC inside your cluster. Okay, because this is important for your security. So we don't have a lot of time. Okay, I'm a little skipping ahead. Okay, this is more RBAC stuff. So again, I've installed also Prometheus. So very easily, if you haven't known Prometheus and Grafana before, it is really the cloud native way to do observability. Okay, logging into my Grafana, okay, which takes data from the Prometheus DB I have on my system. Inside, we have these different dashboards, okay, which can the generic dashboards for reviewing the cluster health and different usage inside the cluster. We have more dedicated dashboards, for in this case for Kubernetes stateful sets, which is like in my case, okay, was in the Minikube was not really nice because for some reason I didn't get the data through. Yesterday when I tried to set up this demo, and also this persistent volume issues, okay, which you can raise in very simple dashboards inside Grafana, which I think is really useful, and those who haven't used them before, I think this is the really right way to look into these things. So this is about the recorded demo. So I wanted to really just for 2 minutes, okay, return to the question of vulnerability scanning. So I don't know if you recall how many vulnerabilities MongoDB had during the scan. Anyone remember? I don't. So it must have more than 20, okay, not more than 50 or 100, okay. The Kubescape operator uses Gripe, okay, which is part of the Anchor project. Okay, it's a great vulnerability scanner, but it's the same for any other vulnerability scanners like Sneak and Trivi, all of them. They're giving you overwhelming results, okay. And if I'm as a security engineer, okay, I need to solve these issues, trying to get updates, trying to get ahead of top of these things, okay, it's really hard because most of the time I need to, in a big cluster, I always have to run and update images. So what I wanted to show you in really a sneak preview of a cool project we've done with Kubescape, which is, let me do the slideshow from here. So this is a vulnerability scan summary of Nginx, I think. Yeah, Nginx deployment. So if you can see, okay, there is a summary here that it has 396 vulnerabilities altogether after the simple static vulnerability scanning. And during the runtime, we've detected only 4. What Kubescape does, I mean, this is the POC project, okay, and we've just released, really the real first version of it, is actually it uses eBPF to detect which software packages are used during the runtime of the pods, and by understanding which are really loaded into memory, we are simply creating a different alternative vulnerability scan results which are not containing those vulnerabilities we are related to packages which are not loaded into RAM. Why is it? Because most of the packages are coming from your base images or build tools, and they are not really used, so they cannot be exploited. So this is really, this is not a real. By the way, this is new. I'm not sure that this is the right result. Okay, because in the sense that this Nginx doesn't do anything. It doesn't even load SSL. Okay, so it is the dumbest Nginx you can ever find, and I'm sure that most of the Nginx you are using, okay, are much more, loading more and more software packages. But I wanted to show you that you can make vulnerability scanning more relevant, okay, and more easy to digest. So this is about us, and hope it was, I did it in right enough time.
You did. It was fantastic.
Okay. Thank you very much, guys.
Thank you very much. Great job, Ben. Great job. Great job.